Welcome to the ultimate exploration of Linux performance in 2026, where we uncover the secrets to achieving the fastest system possible. Transforming the way you experience computing. Linux has long been celebrated for its speed, efficiency, and flexibility. But over the years, these strengths have evolved dramatically. With innovations in kernel architecture, hardware optimization, and intelligent resource management. Today, achieving peak performance on Linux isn't just for developers or power users. It's accessible to anyone willing to understand the system at a deeper level. Performance isn't defined solely by processor speed or RAM size. It's the combination of hardware, software, and configuration that allows Linux to operate seamlessly, respond instantly, and execute workloads without unnecessary delay. One of the most critical areas to focus on is the Linux kernel itself, which serves as the foundation for the entire operating system. In 2026, kernels have become more intelligent. With improved CPU scheduling algorithms, latency reductions, and memory management strategies that maximize throughput while minimizing waste. Modern kernels can dynamically prioritize foreground tasks over background processes, ensuring that the applications you actively use receive immediate resources, while background tasks remain efficient, without interfering. Memory management has also seen remarkable advancements. With smarter virtual memory handling, adaptive caching, and efficient swap strategies, Linux can make real-time decisions about what data stays in RAM and what can be temporarily offloaded, resulting in faster application launches and reduced lag. Even on systems with moderate memory, storage has always been a defining factor in performance. And 2026 brings innovations that elevate it even further. Solid-state drives, NVMe storage, and emerging storage class memory work in tandem with file systems like BTRFS, XFS, and experimental systems such as XFS, delivering ultra-fast read and write speeds, reduced fragmentation, and robust snapshot capabilities. Choosing the right file system for your workload is essential. A poorly optimized file system can bottleneck even the fastest CPUs, while a tuned modern file system can unlock near-instantaneous access to large datasets and intensive applications. The choice of Linux distribution also plays a significant role. Minimalist distributions like Alpine Linux, Void Linux, or Arch Linux allow users to remove unnecessary services and software, dedicating system resources exclusively to essential applications. On the other hand, performance-tuned distributions designed with speed in mind come pre-optimized, often featuring kernels patched for real-time responsiveness, memory efficiency, and hardware acceleration. Package management and software optimization are equally crucial. Compiling software from source with architecture-specific flags, utilizing modern compiler optimizations, and selectively enabling performance-enhancing features can significantly reduce execution time. Even small applications benefit from these techniques, especially when run on systems designed to squeeze every bit of performance from the CPU and RAM. Modern CPUs with hybrid architectures further influence Linux performance. Linux kernels now intelligently allocate workloads across high-performance and efficiency cores, balancing raw speed with energy savings. Advanced threading, concurrency management, and intelligent I/O scheduling ensure that resource-intensive tasks, like video rendering, large-scale simulations, and scientific computation, run faster than ever before. GPUs have become a cornerstone of Linux performance in 2026. Open-source GPU drivers and better kernel integration allow offloading of previously CPU-bound workloads. From complex rendering tasks to AI and machine learning processes, this combination of CPU and GPU optimization ensures that tasks execute efficiently. Leveraging every ounce of available hardware, networking has also reached new heights. Advanced TCP stack optimizations, low-latency protocols, and AI-driven bandwidth management allow Linux to maximize throughput and minimize packet loss. These improvements are crucial for cloud computing, gaming, and remote workflows, ensuring that your system communicates efficiently without introducing delays. Power management and system tuning are no longer mutually exclusive with speed. Dynamic frequency scaling, per-core power adjustments, and predictive thermal management allow Linux to deliver peak performance when needed, and conserve energy during idle periods. For laptops, mobile devices, or energy-conscious desktops, this balance provides both speed and efficiency. Security improvements complement these performance gains. SE Linux, AppArmor, and modern kernel hardening patches operate in the background with minimal overhead, ensuring that your system is protected without sacrificing speed. Efficient encryption, sandboxing, and memory-safe code practices further reinforce performance, while maintaining robust security. One of the most transformative innovations in Linux performance is AI-assisted optimization. Machine learning models analyze workloads in real time, anticipating user behavior, preloading frequently accessed data, and intelligently distributing tasks across CPUs, GPUs, and memory. The result is a system that doesn't just react instantly, but predicts what you need, providing seamless responsiveness for both everyday use and high-demand applications. Tools for profiling and monitoring system performance have also advanced dramatically. Utilities like perf BPF tracing and AI-based performance analyzers allow users to identify bottlenecks, visualize system behavior, and implement targeted optimizations. Understanding where time is spent, whether in system calls, I/O operations, or application threads, enables precise adjustments that maximize speed without unnecessary trial and error. Containerization and virtualization, once associated with overhead, now deliver near-native performance. Linux containers and lightweight virtual machines use hardware acceleration, GPU access, and optimized networking to run isolated workloads with minimal impact on the host system. Developers and enterprise users can now deploy complex workloads efficiently, balancing isolation, security, and raw speed. Desktop environment choice also significantly affects perceived performance. Minimalist environments like Sway i3 or Wayfire minimize CPU and GPU overhead, delivering near-instantaneous responsiveness compared to heavier environments like GNOME or KDE. Even subtle optimizations, such as disabling unnecessary visual effects, can dramatically improve the perceived speed of the system. Boot times and startup sequences have evolved as well. System boot optimizations, parallelized service loading, and intelligent cache utilization allow Linux systems to reach a fully operational state in mere seconds. Users can access their workspace almost immediately, enhancing productivity and reducing wait times. Application-specific performance tuning remains a key strategy. Profiling applications, enabling hardware acceleration, adjusting configuration files, and compiling with optimization flags often yield significant improvements. Databases, video editors, compilers, and web servers all benefit from tailored adjustments, complementing system-wide optimizations. Storage I/O optimization is another pillar of speed. Linux now supports asynchronous I/O scheduling, predictive caching, and RAM-based temporary storage layers, minimizing latency during heavy disk operations. Hybrid setups, combining NVMe SSDs, SATA SSDs, and RAM disks, allow critical applications to operate at maximum speed, while maintaining data integrity and reliability. Security-conscious users benefit from modern encryption, sandboxing, and kernel-level protections, operating efficiently alongside system tasks, ensuring safety without noticeable slowdowns. The ecosystem of optimized tools, libraries, and compilers enables users to extract maximum performance at every layer. Lightweight logging systems, real-time memory allocators, and efficient inter-process communication tools reduce overhead, dedicating system resources to the applications that truly matter. Linux performance in 2026 is as much about perception as raw numbers. A system that launches applications instantly, responds without delay, and handles intensive workloads smoothly feels faster, even if hardware specifications remain constant. Community contributions continue to drive innovation. Open-source development ensures that optimizations, bug fixes, and performance enhancements are constantly introduced, keeping Linux at the forefront of computing speed. Every kernel patch, driver update, and distribution tweak adds to the collective knowledge and capability of Linux users worldwide. Understanding and applying these advanced performance strategies requires both experimentation and careful tuning, but the rewards are substantial. A properly optimized Linux system in 2026 operates at peak efficiency, delivering responsive, secure, and lightning-fast computing experiences that surpass most modern operating systems in both speed and reliability. Whether you are a gamer seeking minimal latency, a developer compiling massive projects, or an enterprise running large-scale simulations, Linux provides the tools and flexibility to tailor your system to your precise performance requirements. From kernel tweaks to AI-assisted optimization, from storage hierarchies to GPU acceleration, every aspect of the system can be tuned to eliminate bottlenecks and maximize throughput. This holistic approach ensures that your Linux machine not only runs faster, but adapts intelligently to your usage patterns, creating a seamless computing environment that feels immediate and efficient. By combining cutting-edge hardware, optimized software, and strategic system configuration, Linux users can unlock performance levels that were previously unimaginable, turning ordinary machines into productivity powerhouses, capable of handling the most demanding workloads with ease and precision. The ultimate speed secrets of Linux in 2026 lie in understanding the interplay between system components, anticipating resource needs, and leveraging both software and hardware capabilities to their fullest potential. This is the future of high-performance computing, responsive, intelligent, and tailored to the user, where every process, every thread, and every byte of memory is utilized efficiently, delivering an experience that feels instantaneous, effortless, and endlessly capable. Thank you for joining this deep dive into Linux performance in 2026. Remember, the speed of your system is not just hardware or software. It's how intelligently you optimize and configure every layer,